Okay, so we're going to finish up our discussion about acids and bases by describing what happens when you combine an acid with the base. Now, an acid has certain properties. We didn't really talk about them, but we will later in the year. It's corrosive. well, it burns. A base has different properties. A base usually doesn't burn. It usually feels slippery, but it's also corrosive. However, when you combine an acid and a base, they neutralize each other, which means they react together, so you get rid of the acidic and the basic properties. And what you end up with when you combine an acid and a base is water and usually a salt, an ionic salt. So let's think about why that is. We said an acid has a proton to donate. So an acid has usually a hydrogen proton bonded to something else. I'm representing the something else by X. It could be HCl is a strong acid. It could be a weak acid like I can never write that one. Acetic acid. It could be hydrobromic acid, whatever. We're using an X to represent the something else. And a base oftentimes has a hydroxide in it. Doesn't have to have a hydroxide, but it usually does. So when you combine this acid with the proton that can be donated and the hydroxide, which can accept a proton, if your hydrogen proton goes to your hydroxide, you end up with, after the reaction, HOH, because this has joined forces with the hydroxide. And over here, in this case, we'd have KX. I did this not totally generically, but this K is potassium and the X is anything else. HOH is another way of writing water. So whenever you combine, or usually when you combine an acid and a base, you end up with water and an ionic salt. That's called a neutralization reaction because on this side of the reaction, there's no acid and no base on this side. What we have is water, which is neutral, more or less, an ionic compound, which is a salt, and a salt is not an acid and not a base. So let's go ahead and write that down. A salt is not an acid and not a base. A salt is an ionic compound, is an ionic compound. So now we're going to practice writing a reaction for the combination of an acid and a base, identifying it as a neutralization reaction, and predicting the products. And we have here, for the reaction between the aqueous solutions of acetic acid, that was the one I couldn't write down before, and barium hydroxide. And so, is acetic acid a strong acid or a weak acid? Correct, it is a weak acid because it is not on the list of strong acids you had to memorize. Is barium hydroxide a strong base or a weak base? Correct, it is a strong base because it's formed with the group 2, heavy group 2 metal and a hydroxide. We're going to combine those. So I've written them down here, and I had to move the arrow like this because I didn't have enough room over here for the products. This is our acid. This is our base. Now, acetic acid is a weak acid, and usually the H in an acid is written up front. We have HCl, HBr, but sometimes, depending on the Lewis structure, this is an organic molecule, but it's an acid, and the H is kind of hanging off here at the end. So now this acid is going to donate its proton to this hydroxide, which can accept it. So if this goes to meet up with that OH, you're going to have HOH, which is water, right? H2O. So I'm going to rewrite it as water. And then what am I left with? The other thing I'm left with is barium from right here and the acetate ion. And next class I'm going to give you a nice list of polyatomic ions, but I know Mrs. Smith and Mrs. Skrzicki's students had to memorize the acetate ion. I don't think I made mine, but you will this year. So it's barium acetate, CH3COO. The acetate ion has a -1 charge. Barium has a +2 charge. It's in a group 2. So for every barium that we have that's +2, we're going to need 2 of these. We'll just jot that to barium is +2. The acetate ion is -1. So you have to cross 2 here, 1 here. That's how you write water. So let's see if we're balanced now. We have 1 barium here, 1 barium here. We have 1 acetate ion and 2 here, so I'm going to have to put a 2 up here. And now I have 2 hydrogens here, and 2 hydrogens here, and 2 oxygens. So 4 hydrogens and 2 oxygens. So I'm going to need a 2 there. Now my equation is balanced. So that takes care of the molecular equation, but we also have to write the complete ionic equation. Well, that shouldn't be so hard. If these are all aqueous, I didn't put the little aqueous after everything, but they're all aqueous. This is going to be aqueous according to the solubility rules. Barium acetate is soluble. I think I should double check that. But I'm pretty sure it is. And water is a liquid. Water is not aqueous. Water, we say, is a liquid. And these two, they told us, were aqueous. So we're going to write all the ions out separately. We have 2 acetate ions here. So 2 CH3COO minus aqueous. We have 2 H pluses that are aqueous. That comes from this one, 2 of them. We have 1 barium. That's aqueous. That's right here. And 2 hydroxides that are aqueous. And now I have to do the arrow like this because I don't have room. These are the products. And what's going to be the products? Well, water here is a liquid. Water is not aqueous. Water is a liquid. We don't say water is dissolved in water. So water is an actual new thing that's been created. H2O, that's a 2. So that is a new product, water. We didn't have water before. And I need to make sure that barium acetate is aqueous. Let me check. I'm back. It's soluble. So we have a barium ion here, +2, and that's aqueous. And we have 2 acetate ions. So I'm going to write that like this. And that's aqueous. And that is our complete ionic equation. Okay, so that is our complete ionic equation. Now the last thing we have to write is the net ionic equation. And I'm going to circle in red, where's red, what will be included in our net ionics. So this hydrogen joined forces with these hydroxides to make water. This water is a new product. It's a liquid. Not a solid, but a liquid, but still a new product. So this plus this made this. This is something new, and we only write net ionic equations for things that are new. So I'm going to write it over here in red. 2H plus aqueous plus 2O minus aqueous makes, oh crumb cakes, I didn't balance it right, should make 2 H2Os. And that's a liquid, and there should be a 2 down here because there was a 2 over here. So this is our net ionic equation. In purple, I'm going to circle the spectator ions. Barium, barium. They're barium aqueous before, aqueous after. 2 acetates, aqueous before, 2 acetates, aqueous after. They're there before and after. So our purples are our spectator ions. So they are not written in our net ionic, which is right here, at the end.